The sun looks calm from 150 million kilometers away, but that calm is an illusion. Beneath its glowing surface, immense magnetic forces twist and snap, releasing sudden explosions of energy known as solar flares. In a matter of minutes, the sun can hurl vast clouds of charged particles into space, each one carrying enough energy to disrupt satellites, cripple power grids, and interfere with the technology modern life depends on. On the surface, solar flares sound like an unstoppable cosmic threat aimed straight at Earth. Yet Earth has survived this assault for billions of years, not by chance, but by design. Hidden from our eyes is one of the most powerful defense systems in the solar system. Earth's magnetic field. Generated deep within the planet's molten iron core, this invisible shield stretches far into space, forming a protective bubble known as the magnetosphere. When the sun launches a solar flare, most of those high-energy particles never reach the ground. Instead, they collide with this magnetic barrier and are forced to bend, twist, and flow along its invisible lines, redirected away from the planet's surface. But Earth doesn't simply deflect the sun's fury, it transforms it. As solar particles are guided toward the planet's poles, they plunge into the upper atmosphere. Where they collide with atoms of oxygen and nitrogen, these collisions excite the atoms, charging them with energy. When that energy is released, the sky itself begins to glow. Curtains of green, waves of purple, and flashes of red ripple across polar skies, painting the heavens with light. What could have been destructive radiation becomes one of nature's most breathtaking displays. The aurora. Each aurora is more than just a beautiful light show. It is visible proof of Earth quietly absorbing a solar storm that could otherwise do real harm. While we watch the sky dance, our magnetic field and atmosphere are working together, dissipating energy, protecting our oceans, preserving our atmosphere, and shielding every form of life below. This forgotten defense is the reason Earth is still a living world. Mars once had a magnetic field of its own, but when it weakened, the solar wind stripped away much of its atmosphere, leaving behind a cold, barren planet. Earth avoided that fate because its shield endured. Without it, our planet would be unrecognizable. No blue skies, no flowing water, no life as we know it. So the next time the sun erupts in a violent flash of energy, remember this: Earth is not helpless beneath the storm. Every glowing aurora is a silent victory, a reminder that our planet stands between us and the fury of a star, turning cosmic danger into celestial beauty. Have you ever stopped to think about what makes life on Earth possible? We often thank the sun, water, and our atmosphere. But there's another, invisible hero working tirelessly to keep us safe: Earth's magnetic field. It's like a giant, invisible shield surrounding our planet, and without it, life as we know it simply couldn't exist. So, what exactly is this magnetic field, and how does it protect us? Let's dive in. Deep inside our planet, about 3,000 kilometers beneath our feet, lies a massive, scorching hot core. The outer part of this core is a sea of liquid iron and nickel, constantly churning and flowing. This movement of molten metal acts like a colossal dynamo, generating powerful electric currents. And as you might remember from science class, where there are electric currents, there's a magnetic field. This is the source of Earth's magnetosphere, a vast magnetic bubble that extends tens of thousands of kilometers out into space. So, we have this giant magnetic shield. What's it shielding us from? The main threat is the sun. Our star is amazing, but it's not always friendly. It constantly bombards the solar system with something called the solar wind. This isn't a gentle breeze. It's a high-speed stream of charged particles, mostly electrons and protons, hurtling through space at millions of kilometers per hour. If this solar wind were to hit Earth's atmosphere directly, it would be catastrophic. It would strip away our atmosphere over time, leaving our planet exposed to deadly solar and cosmic radiation. That's where our magnetic field steps in. When the solar wind approaches Earth, it first encounters our magnetosphere. The magnetic field acts like a cosmic deflector shield. It redirects the vast majority of these harmful charged particles, forcing them to flow around our planet instead of crashing into it. You can imagine it like water flowing around a rock in a stream. The rock is Earth, and the water is the solar wind. Without this protection, our atmosphere would be eroded away, our oceans would boil off, and the surface would be sterilized by radiation. Just look at Mars. Scientists believe it once had a magnetic field that died out, which led to it losing its atmosphere and becoming the barren, cold desert we see today. But what about the particles that do get through? Our magnetic shield isn't perfect. Some particles get trapped in the magnetic field lines. spiraling towards the magnetic poles. When these trapped particles interact with atoms and molecules in our upper atmosphere, like oxygen and nitrogen, they energize them. As these atoms and molecules return to their normal state, they release the extra energy as light, and this creates one of the most breathtaking natural phenomena on Earth, the auroras. The beautiful, dancing lights of the aurora borealis in the north and the aurora australis in the south are a stunning visual reminder of our planet's magnetic field in action, protecting us from the solar wind. However, our magnetic field isn't static. It's a dynamic, ever-changing system. For one, the magnetic poles are not fixed. They wander. The magnetic North Pole is currently drifting from the Canadian Arctic towards Siberia at a surprisingly fast pace. This has practical implications, requiring us to constantly update navigation systems, from the compass on your phone to the systems used by airplanes and ships. Even more dramatically, Earth's magnetic field has flipped its polarity many times throughout history. North has become south, and south has become north. These reversals happen over thousands of years and are a natural part of the geodynamo cycle. We know this by studying ancient rocks, which contain magnetic minerals that locked in the direction of the magnetic field at the time they formed. The last full reversal happened about 780,000 years ago. Are we due for another one? Scientists are still debating this. While the field has weakened by about 10% over the last 2 centuries, this doesn't necessarily mean a reversal is imminent. During a reversal, the main magnetic field would weaken significantly, and we might see multiple north and south poles pop up all over the globe. The shield would be less effective, potentially allowing more radiation to reach the surface. This could disrupt our power grids, damage satellites, and increase health risks. However, it's important to remember that our atmosphere would still provide substantial protection, and life has survived many reversals in the past. It wouldn't be an apocalyptic event, but it would certainly pose significant challenges for our technological society. So, the next time you look up at the sky, remember the invisible force field that's all around you. From the churning core of our planet to the beautiful auroras in the polar skies, Earth's magnetic field is a fundamental part of what makes our world a habitable, thriving oasis in the vastness of space. It's a silent guardian, a cosmic shield, and a testament to the incredible and complex systems that make life on Earth possible. That wonder has guided humanity for as long as we have looked upward. Long before we understood magnetic fields or solar storms, ancient civilizations watched the aurora with reverence and fear. To some, it was the fire of the gods. To others, the spirits of ancestors moving across the sky. They did not know they were witnessing a planetary shield in action, but they sensed its significance. Even without the language of science, the sky was telling a story of protection written in light. Today, we finally understand what those ancient observers could only imagine. Spacecraft stationed between Earth and the Sun act as early warning sentinels, detecting solar flares moments after they erupt. Instruments measure the speed, density, and magnetic orientation of incoming solar storms, giving us precious time to prepare. Satellites can be placed into safe modes. Power grids can be stabilized. Astronauts aboard the International Space Station can move to better shielded areas. These precautions work because Earth's magnetic field buys us time, slowing, deflecting, and softening the sun's most violent outbursts. Yet even with all our technology, we remain dependent on forces far older than civilization itself. The magnetic field is not something we control. It is a gift of geology, born from a restless, molten heart deep inside the planet. If that internal engine were to falter, no amount of technology could fully replace what would be lost. Earth's defense is ancient, automatic, and astonishingly effective, but it is not something we can take for granted. This realization reframes how fragile our world truly is. From space, Earth looks serene, a blue sphere wrapped in clouds, glowing softly against the black. But that calm is maintained by constant struggle. Every second, the sun pushes outward. Every second, Earth pushes back. The balance is invisible, but it is relentless. In that sense, auroras are not just beautiful, they are honest. They reveal the tension between creation and destruction playing out above our heads. They remind us that life on Earth exists not because the universe is gentle, but because our planet is resilient. Beauty, in this case, is the byproduct of survival. As we step deeper into the space age, sending probes to distant worlds and dreaming of becoming a multi-planet species, Earth's example becomes our guide. If we hope to live beyond this planet, We must learn to recognize and recreate the conditions that make life possible here. Magnetic fields, atmospheres, and planetary interiors are not details. They are the difference between living worlds and dead ones, for now. Earth remains our only refuge, a world that has endured solar tempests, cosmic radiation, and the passage of deep time, and still offers life a place to thrive. Its defenses are silent, unseen, and often forgotten, but they are always at work. So when the night sky ignites in waves of green and violet, pause for a moment. You are not just witnessing the natural wonder. You are watching Earth stand its ground, turning the fury of a star into a quiet, glowing promise that life, here, will endure.